This video is going to provide a couple more exercises for math calculations. So we'll go over these step by step in case you're having a little bit of a problem or want to review. So we start with this and it says consider this reaction and notice that it's balanced, which is a big one for us. What mass of water, so we're going to put X grams because it wants to know mass and that's grams, is needed to completely react with 20.0 grams of PCl3. Now, one thing I want to bring out is that before when we've done this, we've looked at like grams of reactant to grams of product or moles of reactant to moles of product. And you can actually do the same process looking at products or reactants together to see how much you need. If I have this much of this, how much of this would I need? Which is not really much different than if you would to go to the kitchen and say, I have this many eggs and in order to make a cake, how many cakes can I make with this many eggs? The same type of process, but of course it's a little bit different because we have more of the math involved. So we still have to do grams to moles, we still have to do a mole to mole ratio, and change back to grams if the problem asks for it, and that's what it does. It says it wants to know grams. So let's start at the beginning. Let's take grams to moles. First thing that we have to do is to get the molar mass of PCl3. We know that phosphorus weighs 30.97 grams per mole. Chlorine is 35.45 when we round it. So it's going to be 30.97. 3 times 35.45 is going to be 106.45. We're going to add 30.97 to it, and our molar mass is 137.32 grams per mole. And we're going to need that information to change 20 grams of PCl3 to moles. So put 1 mole on top, 137.32 grams on bottom. So we take 20 times 1 divided by 137.32, and we have 0.146 moles of PCl3. So we've gone from grams to moles. Now we do our mole to mole ratio. We start with PCl3, and we're going to put H2O here because that's the one that we need to know. Our balanced reaction tells us that 1 PCl3 reacts with 3 waters. Our problem tells us that we have 1.46 moles of PCl3, and I need to find out how many moles of water that would require. So we cross multiply. We take 0.146 times 3, and we have X equals 0.437 moles of water. The problem doesn't ask for moles, the problem asks for grams, and we're going to come over here and find the mass of molar mass of water. So we have 2 hydrogen at 1.01, we have 1 oxygen at 16, so it's 2.02 plus 16, 18.02 grams per mole. I'm going to come over here and I'm going to take that information, put 18.02 grams over 1 mole, make sure my moles cancel, multiply, and I get for an answer 7.87, and that's going to be grams of water. Put a box around it, and that's the answer. So in order to get full credit for a problem like this, I expect to see the steps written out like this. One last math calculation that we're going to look at is a little bit different because it asks us to consider the following reaction where we don't know what X is. And it says, I'll walk you through this one. It says we have 175 grams of X. Write that down there. And it reacts with diboron trioxide to produce 2.43 moles of B4X3. What is the identity of X? When we look at this, we know that we have to look at mole to mole ratios. We have grams to moles. We have to look at that, do a mole to mole ratio, and get back to grams again. This does give us a piece of information that doesn't look extraordinary to start with. This element X is by itself. and we have 175 grams of that element. Because we're not given the molar mass of X, this doesn't help us a whole lot. We can't change that to moles. When we look over here at the B4X3, it does give us moles. So this inadvertently gives us the information that we need to answer the question. So let's go backward. Let's start with moles and go backward to find out what X is. From the balanced reaction again, we have X and we have B4X3. The balanced reaction tells us that it should react 6 to 1. There's a 1 in front here. The problem tells us that we produced 2.43 moles. So let's go backward and find out how many moles of X that is. So if we cross multiply, X equals 6 times 2.43. 2.43 times 6 is 14.58 moles of X. What we really need to know in this case is we need to know the molar mass of X. Well, let's just look at the information that we do have. Change it to a different color. We know that molar mass is in grams per mole. We also know that 175 grams is how much 14.58 moles weighs. So if I take 175 and I divide it by 14.58, I get 12.00 grams per mole, and that's the molar mass of X. So we need to, first of all, find X's identity. So we go to the periodic table. We want to know which one weighs about 12 grams per mole, and that would be carbon. So the identity of X is carbon in this case. Again, it takes practice to get these calculations correct. It's all about how organized you are when you do your problems, and it's all about how careful you are looking at the information that you have and going to where you want to go. You have to know always that you're not going to go from grams straight to grams, that you're going to go grams to moles and then do a mole to mole ratio before you can go back to grams. And I can start here and go here. I can start here and go here. It doesn't make any difference. I can do that with two reactants. I can do it with two products. I can do it between reactants and products. So just the biggest thing with this is just to be comfortable with it so that we can understand the next concept, which is about limiting reactants.